I started out at Cisco, I was a customer. I've been doing this for almost 30 years now, so networking. And I started in the military, U.S. Air Force, and I actually traveled with President Reagan, so that's how long ago it's been. I've been outside of Cisco as a customer, a buyer, and a user of technology a lot longer than I worked for Cisco. I came to Cisco in 1999 when we started this IP telephony thing, this voice on a data network and converging the networks. I was a PBX guy who knew routing and switching, and I'd handle the role of telecom manager and everything else. So they were hiring expertise, and they got me. They were looking for expertise, and they got me. So I was an SE at Cisco. And again, you'll have, if you're account managers and account team members, you'll have what we call PSSs, product sales specialists, overlays, who will help you with those specific technologies, because back when I started, we were a routing switching company who was selling voice. But we've complicated this stuff. Networks have never been more complicated. And that's a problem. It really is a problem, because our customers expect it to look easy, and it's not. From a networking engineer perspective, it's harder now than it has ever been. But the thing about it is we boot up our PCs and they work. So customers expect that. They expect everything to be magic anymore. And the acceleration of technologies, transformational technologies that we have is just amazing. So this is actually one of the things that my SEM gave me. My task was to train new account managers in my own team, because we were hiring a lot of people from outside of Cisco who didn't have industry experience from routing and switching or any kind of networking, but they were great salespeople. And my rule of thumb is, give me somebody who can sell. I don't care if they know technology. I can teach them technology. I can't teach them sales. I don't know sales. I'm an SC. So they did that. So the first 3 to 6 months, this class was built on what I used to talk to them about on napkins and sitting over dinners, late dinners, or lunches, or breakfast, whenever it was, and say, this is why we're talking about this. This is how this works. And what they did is they finally came to the realizations we need to do that for everybody at Cisco, at least all of our sales teams, the people who are carrying quota and the people who are really affecting our business, the bottom line. So it'll be whiteboarding. You have an agenda in front of you. And we'll go over this. Now, I know that we have certain members of our audience here probably are service provider. How many people are service provider focused here? Yeah, a few service providers. I apologize up front. We're not going to cover the big iron, the really big stuff. I love that stuff. I love going in and looking at it, touching it and feeling it. God, it's really nice. But we're really going to focus more on the enterprise, select and commercial product set and everything. I hope we can talk about some of the things, but again, our service providers a lot of times are actually, and more so now than ever, are actually selling to the customer the way we should be selling to the customer. So we may talk about that in the back end. Here's what they're putting in the back end, especially with collaboration, some of the collaboration things that we're doing. And that. So I just want to set the expectations up. The reason we have a guy in the camp, we usually don't have this guy in the back who's doing the recording. We try to do this, record this every so often. It's been several years since we recorded it. We have new technologies, new architectures, new all this, that, and the other since it was recorded, so they chose to do it this time. So I'm wearing a microphone, so I have to be careful what I say now. It's a lot more than I probably would. But this class is all about you. If you have questions, this is the place to ask it. This is going to be 3 days of your class. If you have a question, ask about it. It's, I might not have the answer, and I'll tell you if I don't. But if I do have the answer or why I think certain things happened the way they did, I'll tell you. I left Cisco in 2004 on my own accord and started my own consulting company. That's where that KEM consulting comes in. So actually, I sit on the other side of the table now. I'm hired in to go and talk to customers about technology. A lot of the times you might have instigated the conversation, but I'm the one that they turn to say, is this what the salesperson's really, what are they talking about here? And how's it really going to affect my business? How can it affect my business positively? Or is this something that I really don't need to look at? Or how can we adapt this? So it's kind of fun to be on that side, because I get to hear a lot of what they used to say about me and what I used to say about my vendors and customers and people who were coming in and talking about my business. So the first thing we're going to do is talk about the OSI model, understanding the OSI model. Now, the OSI model, has anybody ever heard of the OSI model? Sure, a lot of us have and everything. So the OSI model, it's been around for quite a while, longer actually than I've been in this business. And the OSI model was originally set up during the birth of what networking became. Because before then, we had, at best, you had a mainframe. You had a proprietary network that connected to everybody to the mainframe, all centralized. And then they started creating, and everybody could access through dumb terminals, the old 3270 emulators as terminals that were out there. That was the way all networking happened at the time. Very proprietary, very closed. And then all of a sudden, people started building these new personal computers started coming about. And people wanted to try to figure out how to make communications flow for that. I find it's really funny that the first time that, when I came out of the military, I went to work for American Airlines, which was the largest private data network in the world at the time. It was mainframe based in Tulsa, Oklahoma, and it ran the Sabre system, computer reservations for airlines. And at any one time, back in the mid-'80s, we could have 140,000 people accessing that mainframe, that IBM mainframe. Man, we beat that thing to death. And then everybody used these old dumb terminals, Raytheon terminals, ICOT terminals, somebody's terminals. And then PCs came about. So a terminal cost us about $75 to $85 for a terminal. It only had two colors, either green and black or orange and black. And then we replaced it with a personal computer that cost $4,000. We put it on a separate network that we had to install. And then the first thing we did was load a terminal emulator to make it look like a terminal. Now but we did it all for productivity, right? That's what we did. All of a sudden, typewriters went away. People didn't have to type. Printers could now be networked. We didn't have to have, people could print easier. All these things started to happen. And during that time, the evolution of what we consider networking today, there was a lot of competitive technologies. A lot of companies were coming out with their own version of how networks should look. And they didn't always work together. Matter of fact, IBM came out with their first PCs, and American Airlines bought a whole bunch of them. We put them all in and got them finally working on Token Ring. And then, boy, it was great. I love Token Ring. And then they came out with some newer PCs, faster processors, from the old 8086s to the 8088 models and the 186 models. And then they changed the type of Ethernet connector they're in, and they wouldn't even talk together. They wouldn't even talk on the same Ethernet network. So networks wouldn't even work together. Token Ring wouldn't work with Ethernet, and Ethernet worked totally different. You had to understand. And eventually, they had to have some way to make sure all of this stuff worked together. That's what the OSI model did originally. Now today, we don't have to worry about that. Ethernet's one. All of us old Token Ring guys had to get out of it. They had to, lick our wounds and go on. All the people who did FIDI and ATM and all those technologies have gone to the past, and we just have Ethernet. And I joke about it. I generally joke about it later on in class, but how do you spell Ethernet from a Cisco perspective? CISCO. That's how you spell Ethernet. That's how you spell it, because we've done, when I came to Cisco, I could sell a customer a Token Ring switch, an Ethernet switch, or an ATM switch. We let the customers decide what technologies they wanted to use. Well, they decided. So we don't sell a lot of ATM switches, and we don't sell a lot of Token Ring switches anymore. Matter of fact, we don't sell them at all. We can adapt it on a network, but we don't sell the core products anymore, because Ethernet is one. But the OSI model actually, for salespeople and the organization, it's a great way for us to start understanding why networks exist. Now, we've got some SEs in here and all this, and I love asking this for SEs. Why do people buy switching and routing? Think about that. Why do customers even invest in switching and routing and wireless and all this stuff? Why do they invest in it? It's to get to the applications, right? It's the applications are the most important thing in the world to a customer. So in the OSI model, I'm going to show you the OSI model from layer 7 all the way down, which is un-Cisco-like. And I want to try to relate this back to why a customer would use it and how we need to have these discussions with customers. Because I think it's really important that we frame this. The switching and routing and our sales will come if we can actually get a customer to envision what we want they need to run their business. Because the only reason the customer buys a router and a switch is so he can access an application. That's the only reason. So that's why I always start at layer 7, the application layer. And it's the, I'll write it up here. That doesn't tell you a lot, does it? A finite set of protocols. What's a protocol? What's a protocol? It's a set of rules that we have, right? Has anybody ever watched 24? Remember the old TV show 24, Jack Bauer and all that? They were always talking about, oh, we're running this protocol because of this, and we're running this protocol because of that. It's just a set of rules that we have. Applications are just sets of rules across the network. It's a finite set of these rules, of these protocols. There's only so many we could have used to access network resources. If you want a network printer, it's how we actually talk to network printers. If we want to get to a server and connect to a server to the, a web page, whatever it is, it's that finite set of protocols that go across there. And it's the only reason, the applications are the only reason the customer buys switching and routing anyway. That's the only reason they buy it. And it's really, I'm not the smartest, I'm not the sharpest knife in the drawer or anything you want to say. And it took me a while to figure this out. And it took my best friend who was started his own business. My best friend, growing up, became a chemical engineer. Went to Virginia Tech, became a chemical engineer, materials engineer, which is one step below chemical. And started working in the naval shipyards in Charleston, South Carolina, working on nuclear submarines that would come in, and they would refit the submarines and test all the material that comes out of them and all that. And all of a sudden he decided he wanted a career change. He wanted to move back to where we were from in the coal fields, where coal mining is big in the southwestern part of Virginia. And he wanted to open a home health care company because he wanted to move back home. He liked where we grew up in the country and the mountains. It's a beautiful place. And so he started a business there. And when he started his business, in this business, and again, he provides a service to a customer at home, and then he builds an insurance organization for that. So doctors will write orders in the mining fields. People have lung problems. They may have things that they have to have done at home and all this. And he provides that service so they don't have to stay in a hospital. So it's better for the insurance companies, it's better for the hospitals, and he gets his little bit of the money out of it. And when he started doing that, he would provide a service, might be an air compressor so you can have pure oxygen if you have lung problems, whatever it be. And then he would have to bill the insurance company for that. When he started doing this, he used to bill it through what we call snail mail today. He used to fill out a form. Here's the doctor prescribed this. Here's what we're doing. And he'd fold it up, and he'd put it in a letter, and he'd mail it to the insurance company. And then 95 days later, he'd get a check for that if he was approved on the first time. 95 days before he got his money. Not a very good thing. And then somebody knocked on his door and said, guess what? We have this application, this server that we can put out here. This one device that runs an application on it, and you can, from a terminal or a PC that's connected to that server, you can actually input this, and you can use some new technology called a modem at the time. And you can dial up and give it to that insurance company, and guess what? If you invest in this server, and this terminal, and this application and pay us for it, we'll put it in for you, and we're going to reduce that 95 days to about 70 days. Would you be interested in that? What do you think Max said about that? Absolutely. 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 He started buying all this equipment, putting it out there and all this, and this equipment has to be serviced and all that. He didn't even know where some of his equipment was after he got successful. He's running around. Then he said, wait a second. I need multiple people to do this. I've got people going out this way, this way, this way. So guess what? Then we had to put some kind of networking device in here so multiple computers can connect to it. So the first network was born. We didn't have a terminal directly off of that. We could put it on a network. So now multiple people could do that and use that modem. That's why networking exists, is so customers can do that. It's fundamental. It's fundamental. And then somebody came up to him and said, guess what? We have another server out there. Because you've got all this equipment out there, you don't even know where your equipment's at and when it needs to be serviced and everything. We have an inventory database application that will help you know when all your equipment's at and all that. Would that interest you in your business? Absolutely. It keeps me from having to run and do all this. So guess what? We hooked that up to a network. And then he started doing home health care nursing. He has home health care nurses who go to the house and provide treatment, shots, whatever it is. I don't want a shot from anybody, but if you have to, I'd rather have it at my house than go to the hospital. So guess what? He was just sending them all over the place, not knowing where they were and everything. He said, you know, I need to schedule just a little bit better. So he got a scheduling application that worked with all this stuff. So if you meet Mac in a bar, and that's probably the place, if he's out near you, you'll probably find him in a bar. If you meet Mac in a bar and you start talking to him and ask him, what's the most important thing for your business? Guess what he's going to say? He's not going to say it's a switch or his router or anything. What's he going to say is the most important thing that keeps him his applications? All of a sudden, you know, they started using other kind of technologies, you know, the birth of the internet. And now what? He doesn't have to dial in. He can actually send it through the internet through a network. Well, we got to have another device for that, a router that does that. So networking does nothing but support his applications. Nothing but support his applications. That's what he'll tell you. That's the most important thing for him. Even though routing and switching is near and dear to us. How much is routing and switching of our portfolio? How much do we make of our total hardware pie? How much is routing and switching for Cisco? More than 50. 52%. 52%. 37%, 35 to 37% is going to be switching, and the other part's going to be routing. Yeah, that's what we call our core products. But they're only there to support applications. That's the only reason the customer cares. Now, Cisco cares a lot. There's a lot of difference. A lot of difference. So we have to make sure that we're effectively communicating the value of networking to customers and what they want to hear. And that's really about their applications and how we can make their business better. Because every little bit that he's added on there today, Mac's down to he went from 95 days to about 45 days of when he can get paid. Now, if you come up with some kind of technology or you have an ability to go in there with a networking solution that can cut that down to 40 days, don't you think that's probably the way you need to present it to Mac? Instead of saying, I have a new technology, it's cool. Because only geeks like us SEs care about that. And we have no money. None at all. I have a wife and 2 daughters. I tell you, I have no money. I'll tell you stories about that all during the classes and everything. But this is what he cares about. We have to articulate our business value to customers based on what they see as value. Because routing and switching is cool, and we've got some great, great products. But the network only exists for the applications. The applications being able, think about it. He eventually had what we call a WAN, a wide area network. He's got 5 other locations now. So he's got routers out here at all these locations. What if all of a sudden some young person that he hired here and some young person who works out here off a PC, they all of a sudden get the latest copy of Doom or whatever the game is of choice today to play across the network where they can fight each other and everything? What if they load it up and they say, hey, listen, load it up. While we're sitting at lunch, you know what, let's play this across here. What's that going to do to his network? Yeah. So we've got somebody over here sitting beside this person who's trying to input billing over here in this server, and somebody who's playing a game trying to shoot all this high definition video across there, across a small pipe. What happens? Our networks had to be smarter. What we call QoS is prioritizing. Our networks had to become smarter to prioritize these versus anything. Because that's what the business, if Matt can sit down and say, here's my priority. This server, and this server are number 1. And everything else is number 3. Figure it out. Shouldn't your network be able to reflect that? Well, it takes a level of intelligence in that network, and that's what Cisco does. That's what we did back in the early to mid 90s, and later on in the 90s. We invested millions and millions and even billions of dollars in making our solution smarter so they can determine as a packet or a frame moves through the network, what's in it. And do we put it first or second or third or just hold it for a while until we can get our business through there. That's called QoS. We really started using that when we put voice on data networks back in the mid-90s, late 90s, and of course now IP telephony. The network has got to reflect your business goals. And a network can, if it's intelligent enough. And that's what Cisco does. That's what we sell. We sell the most intelligent routing and switching and networking to what? Support your applications. We actually sell you applications today. When we get into, on Friday, when we get into the collaboration, I'm going to tell you all the different applications we sell for collaboration. A bunch of servers. And you'll see that we sell a lot of applications too. And guess what? Those same routers and switchers have to provide services and QoS for that across the network, or it's not going to work. And the customer's not going to get what they pay for. Does that make sense? The application layer is it's the most important thing. And us SEs, we love to go in there and talk about, what routing protocols you're using, all these acronyms that we use. And again, Ciscoese, I call it, the us SEs like to talk about. But really, when it comes down to it, a customer's trying to run their business. They don't wake up today and think, God, this is a terrible time for economics and all this. Buy me a switch. Give me a router. They don't care about that. They care about their business surviving. They care about their business being more productive. The bottom line growth, top line growth, whatever is important to them. How am I going to look good in the market? Marketing. People think about that. That's what their business. We need to address that through our solutions whenever we talk to customers. And again, there's sometimes in accounts we can actually talk that. And we, strategically, if you're in I think you're in the select market, so you won't have as many accounts as a territory account manager. Territory account manager might have, I had one person say, I got 1,200 accounts. Well, hard to be strategic, right? Hard to be strategic. But you know what? If you can at least ask a few questions to try to be strategic with that customer, you can differentiate yourself than somebody who's just trying to push a box. And we need to do that. We need to have the ability to discuss how networking can effectively help a business. And that's all it is. That's all it is. And that's what I do as a consultant. I go in there and say, yeah, they're trying to say this, but this is how I think it would work best for you. And it may work right, The implementation of it sometimes makes all the difference. All the difference. So the OSI model is really, starting with that, is the application layer is really the most important one to me. One layer down, layer 6.
Can I ask a question?
Yes, sir. Yes, sir.
You mentioned the word server
in
all of this, in that diagram. Where is that?
That server's in what we call a data center maybe, or it might just be in a floor setting. Mac had them stacked up on a big rack. I have to help him put a rack in. He just built a rack and put servers in there and connected it.
You're not saying it's part of this network architecture right now?
Well, it's a user on a network. It's a resource on a network. It is one of the resources on the network. It is an application that is in essence a resource for users. It really is. It's a resource. Just like a printer or anything, but it provides a specific need. If I have a client, if you think about client server, I load a client here, and I have a server here. That's client server. That's how simple it is. Client server. Whether it be browser-based or whether it be a specific client that I have to load specific software for that specific application. And it has certain characteristics that the network should be able to look at. If the network's smart enough, it can see that come through the network and say, hey, that's that billing application. Now, it doesn't know it's a billing application. It just knows it's priority 1. These characteristics are priority 1. I put it in front of anything else. Because networking is just managing bottlenecks. It's like a road system. It's like a road system. It's managing bottlenecks. Did I answer your question? Yeah. I don't want to use this color. I try to stay a little bit color. There's 6. So this is an adapter. This is all the presentation layer was just an adapter. So you've got all these pretty little pictures and all this nice documentation you want to send across the network as ones and zeros. This is actually the layer in the OSI model that adapts a picture to a JPG file so we can send it across. The application sees it as a picture, an object, and we see it as a JPG file, or MPG. Whatever it is, we adapt it. Text becomes ASCII or EBCDIC or something like that. This is just an adapter to adapt everything you're sending across the network so we can make it ones and zeros eventually and send it across the network. My dad would call this an adapter. That's what my dad would have called it, an adapter. And that's what it does. But it also does some other things. We've added to what the roles and responsibilities of this are. Let's just think about this. A lot of the applications that we talk about, might be, let's just think about web browsing. When you go across, when you have all these applications that we talk about, some of the applications, if you're using a web browser, how many web browsers can you name? Let's name some web browsers. All right, we got Chrome, I heard Chrome, right? Internet Explorer, right? Firefox, right? There's a lot of different all of those applications use one protocol over here. Guess what that protocol is? HTTP. Wow. There's other things. If I want to move a file across the network, if it's PowerPoint, then let's say that I have you have a PC on a network and I tell you, guess what? I have a PowerPoint presentation that I want you to use with all your customers called sales.ppt. You show that to a customer and 70% of the time they're going to buy from you. You'll certainly want to take that with you, won't you, on your laptop. Well, you move it across. Networking, do we see PowerPoint go across the network? No. The people who wrote PowerPoint actually said, there's a protocol, standard protocol to move files across the network called File Transfer Protocol. So the people who wrote PowerPoint actually said, I don't want to worry about all that. I'll just use File Transfer Protocol to go across there. If I want to send mail from one mail server to another mail server, simple mail transfer protocol. If I want to do network management, sit with network, SNMP. All these are just standard applications over there that you can leverage from your application. All those are the applications we see start on the network and then we adapt them over here to where we can actually use them in ones and zeros and packets and frames later on. But let's just think about this. My wife, has it been? It's been 30 minutes, so I'm cool. My wife thinks the internet was only created for 3 things. Yeah. Somebody got the first one, shopping. Shopping. Right? Yeah. No, not Facebook. My wife doesn't have a Facebook page. She lives through mine. My wife lives through my Facebook page. I don't even touch my Facebook page. She has friends through it. But so shopping. Yeah. Email. She loves email. She comes from a large Italian family up north in upstate New York, and she's got cousins all over the country. They don't live in the hometown anymore. They everywhere. So they send emails and this, that, and the other, keeping up with what's going on with, oh my God, Joey's girlfriend, she's terrible to him. All these little things that are going on. And information. She loves to read papers and find out. She loves to continue to know what's going on, all the gossip columns of what's going on with Kim Kardashian, and all the Kardashians really worries her out, to death. She loves to look at her hometown newspaper and see what's going on there. Did you hear who got arrested? They did DUI. They've been drinking for years, the whole family. She knows all about all that stuff. Reading the New York papers and all this, keeping up with, she's a big New York Yankees fan, so she knows all about A-Rod and his surgery and all this. So she keeps up with that, so information gathering. But shopping is really one. And you know, when we started dating, I never knew what a Talbot store is. Have you ever heard of the store Talbot's? No, I know it's maybe, it's not a global company. But it's a company, ladies' clothing, and it's expensive. I mean, anything. I mean, you just put a price tag on it. Who cares? I don't know where they come up with the numbers and everything. But when we first started dating, we would go into malls and we'd see these, their signature is a big red door. And what my wife would do is when we started dating, I never went into Talbot's until she drugged me in there and I looked at this clothing. She goes, how does this look? And of course, the standard answer is, looks great. You look great in that. You know? You look at the price tag and say, not so great, in your mind, but not out loud, right? And you think about that. But the Talbot, she dressed, and you know, she looked good. She's a hottie. So I really enjoyed that. But with the birth of, this was before the internet. Now the birth of the internet, guess what? She can combine some of these things. Talbot sends her emails. Hey, see the new spring, they're already sending the spring fashion, what the spring will look like. And she can actually buy that today. They'll send her an email. See the spring fashions that... Now, why does Talbot's do that? Why does Talbot's do that? Oh, yeah. We compete globally today, right? She doesn't have to get dolled up and go out to the mall. What she can do, she just sit at home and just answer her email and say, oh, wow, let me look at that. We went to a wedding this past summer, late summer, we went to a wedding. And I know she bought 3 or 4 dresses for it. I said, what are we doing, a wedding or a fashion show? It was my idea of it. But she was doing all this stuff and everything. But she was, and if you buy the dress, you know, you got to get the right shoes, and then you got to get the right purse or pocketbooks, what I call them. All these different things that you got to have. Well, she can sit at home and through her email application, she can actually get all this information and she can actually purchase online. So all she does is she's got a PC here. She goes across this great big network called the internet, and Talbot's have got servers, web servers out here. Now they better have 2. Why do they have to have 2 web servers for this? Yeah. System uptime, reliability. Servers are like light bulbs. How many times have you walked into a room, flicked on the lights, and they work 99.99999% of the time, and then you turn it on and it doesn't work? It's a piece of electronic equipment. So what? We have to have redundancy. Scalability. Early on, they didn't have all these quad-core and octa-core processors and all this. People had to have multiple servers on there. So my wife, Talbot's has got that. So she goes to Talbot's through her mail and she sees this and she says, oh, I want to buy that. So she puts all this stuff in her cart, right? She goes and says, I'll take this and I'll take that and I'll take this. And then eventually she hits that magic button called checkout. Checkout. Now what's she about to do? She's about to put my credit card information into their database so they'll charge, right? It's mine. She knows all my credit card numbers and everything. And it's going across the most unsecure network ever created called the internet. It's the most unsecure network in the world. So guess what? In order to do this effectively and make the internet from a Talbot's perspective and more importantly from a customer's expectation is it's going to be secure. So guess what? We had to come up with a whole new application layer protocol to do that. When she types that, when she hits that checkout button, do you notice that it actually changes to HTTPS? Why? It's secure. Yeah, that's a little company called what? Netscape came up with this. It actually creates a secure tunnel between here and there. Between here and there. Why? Because she's going to put my credit card information across the most unsecure network in the world. We'll talk more about that a little bit later. But there. So she actually changes application layer protocol. So the presentation layer actually does this encryption. We actually had to add it here. So now not only are you converting this from all this rich pictures to ones and zeros and frames of files we can send across the network, but we actually need to do some encryption. So at the presentation layer, we actually start doing this. So this is where secure socket level So secure socket layer encryption actually happens at the presentation layer. And what it does is this PC here starts encrypting it, putting it in a special code that only this PC and this server knows across this, so we can do a secure transaction. Well, this happened back in the late 90s, the internet, all this. And I can still remember there used to be articles. Will anybody ever turn a profit on the internet? I don't know if any of you remember that, but I remember the articles saying, how are people going to turn $1 on the internet through this web, you having web portals? And there were a lot of articles for many years about that. It was before Amazon and all these people, but people were wondering how they were going to do it. So guess what? If we're going to do this, back then we didn't have all these, again, these quad-core, octa-core processors and everything. If they were successful, Talbots might have 5,000 people trying to buy at one time. Do a big email blast, and then guess what? All these people see it. They're like my wife. They want to buy it. Especially that next email that comes. You know, they send an email out saying, here it is at full price, and then 3 weeks later, here's 30% off. Here's 40% off. And at 40% off, there's a mathematic formula, I can't figure it out, that actually if you don't buy it, you lose money. Because my wife uses that on me all the time. It was at 40% off, right? So we know that. So now we've got this encryption. So it takes a little bit of processing power to do this encryption. My wife's never complained about the PC slowing down, but let's think about it from the idea of Talbots. If they're successful with these slower servers that we had at the time, back in the late 90s, that means that this server was sometimes spending 30% of its whole utilization doing nothing but doing this encryption for all these different tunnels. Wow. That means what? It means if I'm successful, what do I have to add? More servers. Wow. Servers are like children. Servers are like children. You know, I don't know where the ROI is in it because I've got 2, and boy, 15 and 13 right now, and my life's a little it's a lot more complicated than it's ever been. But I can remember when Emily was born, my oldest. She was 4 pounds 11 ounces, really small baby, but healthy. They handed her to me when she was born, and I looked down at her, and like any proud father, I said, I'm going to give you the best possible thing, you know. And then, you know, she started to walk, and she would hold my hand, and I felt so good. And now she's a teenager, and she's driving and asking about what car, and she's picking every expensive college she can find and all this, so it's not as pleasant. But servers are like children. There's a lot of cost involved in it. What's the cost in a server? What's the cost of a server? It's not just a PC. What's the additional cost in servers? Electricity, power. You get a bunch of these servers together and all of a sudden it gets hot. Right? So you have to draw a lot of electricity and the room starts getting hot and they don't like hot rooms, so you have to put special air conditioning in for them. You have to buy these applications. Some of you people with Oracle and all those people, these are pretty cheap applications, aren't they? Right? All those applications that you have in the back end of this, they ain't very cheap at all. And then you got to hire somebody who knows how to manipulate those databases and keep them clean and all this. It's kind of like you buy the server and there's a lot of additional cost on the back end of that. Just like children. Just like children. That's why I compare it to children. Yeah. So back in the time, if a customer was starting to try to turn a dollar on this SSL was great for the customer, and it was a requirement to actually sell this, but this was something we needed to do a little bit differently. So Cisco, back in the late 90s, said, you know what? We can actually do this. We can do this in a network. What if I could go to these people and say, I know you're thinking about buying more servers, and the costs associated with those are great. What if instead of buying that server, I could actually give you a piece of equipment that resides inside of your network, a network device that does that SSL termination here and just sends you clean text inside of your data center where it's secure. You wouldn't have to buy that server. And that same device can do server load balancing, can actually look at the servers and say which one's best available. Cisco at the presentation layer is actually the example of Cisco letting the network do more than just push packets through the network, but provide an additional layer of intelligence. And Cisco sells that. They acquired a whole company to do that and put it inside of one of our devices so customers back in the late 90s and early 2000s who were trying to make money with this could do this more economically, because we were doing it in hardware here that scaled much better than any software could ever scale at the time. That's what Cisco's doing all the time. We're always adding services in there that make it work from a network out. Because guess what? Back then they'd have to add more servers, which was inefficient. This way they could just add this device in their network and scale it more. Just add what you really need. The network provides these services. QoS, quality of service, now it actually does SSL offload, what we call SSL offload. We continue to do that today. There's a lot of different services in the network that we have to have. When you think about video, video's the big thing. Emily loves video. And she likes to do video point to point, but she also would love to do it point to multi-point. So she could bring her and Mary Kate and all her, Lexi, her friend Lexi, and they would love to have a little gripe session about the boys at school and all that. But it requires a bridge, a network service that allows that to happen. That's what we sell. We sell the ability to turn on and use that technology and make it more efficient.
Use hardware products?
Yes, absolutely. Yeah, they're a combination of hardware and software. All Cisco devices, I have that question all the time, is it hardware, is it software? And we'll talk about that when we get into switching and routing. But all Cisco products are Cisco software, what we call iOS, and uniquely designed hardware to work with that, because we design our own products. Have hardware that does certain things in there, and our software makes it very efficient and easy to use. That's what we do. Does that make sense? And again, it's all about what the customer wants to do. What the customer wants to do. And in this case, they were trying to turn a dime on this. And eventually, companies like Amazon and everything, they have all these resources to do that today. They have tons and tons of hardware equipment that do this, so they don't have to do it so much in the server. It's much more efficient that way. Much more efficient, especially when we didn't have all these huge multi-core processors that we have today. But Cisco was doing this back in the late 90s. We saw this trend in the industry. We saw this evolution, this need for technology, and it would help the customer. So we would go in there and say, hey, listen, are you trying to get on the web? Yeah. Are you trying to, how's that working for you? Well, our servers are starting to give up the ghost. We got to get bigger servers or more servers. How would you like to not have to do that and get away from that? And we brought them value, related back to their application of their business. Does that make sense? Yeah. That's all it is. It's not rocket science. Layer 5 is the session layer. And now we actually get into some, this is where the handshake happens. When you think client server, the session layer, you'll hear SEs talk about, well, they're setting up a session there. It's the handshake. It's the client talking to the server for the first time. So at the application layer, you click on an icon for Chrome or whatever, and it's actually going to go out to the internet and connect up with a server, a website somewhere. That's what it's going to do. And that first, or a private application that you have, it's the first handshake. It's going across there saying, hey, I'm Eddie, I'm the client, you're the server. And here's the rules that we're using. I'm going to be transferring a file. Today we're going to be using the file transfer protocol. You understand the rules of that. And so it's the first place, the highest layer, where a client or a PC talks across a network, whatever that network is, to a server that's going to provide that service. It's the first handshake. It's just hey, we're going to have communications here. It's that handshake, that first setup of, hey, I'm going to be talking to you. Okay, I understand the rules, and now let's go. The highest layer that communications happens on a network is the session. We call it, you can sit and watch it on a network when you're analyzing a network, you can see sessions set up. So let's just think about this. What if this is your mail server? You have Outlook, right? Outlook is an application, and it's going to use a protocol, POP3, IMAP, whatever it is, to actually go to that mail, right? So you double-click on the icon for Outlook. It opens up the client, and the client's got configuration to go to this server and say, hey, I need you to download my mail. The first thing they do is they set up a session. Well, we have to watch what happens on these devices. Because as soon as we started using applications, every time a new application or a new use of an application comes out there, we have to worry about these people who are a little bit twisted. These people who plant viruses in these applications, the people who want to steal our data. There's always these people who want to do that. And you know, I noticed that nobody brought their desktop in here. So we've all got these mobile devices, so you have a laptop or a mobile device that you want to use, and you can connect up to many different networks. You could take your laptop to Starbucks or to a hotel and get on another network, and those other networks might not be secure, and then you bring it into Cisco and you hook up to the mail. What if you get one of those little bugs called viruses on there? Right? What if you're the first person to get some kind of virus? And that virus is designed to do nothing but drive your mail server crazy. You connect up, innocently enough, and what's it do? It just starts pinging that server and trying to drive its utilization out of its mind. Right? We put antivirus on there, and every time we put antivirus on these things, what happens? They change the way it looks, and we have to update our antivirus over and over and over. What if we could protect this in the network? What if the network was smart enough to know the rules of this protocol, of these protocols? What if you're using POP3 or IMAP or whatever we're using, the protocol, and we could put a device that watched it as it transferred across the network? Could we protect our server better that way? Absolutely. Absolutely. Not have to worry about the server so much. Well, that's what we do with this. We actually came out with a whole product line. Intrusion detection. We came up with an intrusion detection solution. I'll turn this to where hopefully the people on the other side can see it better. Intrusion detection. It was a device that sat inside the network, and we said all the people going to that mail server, we're going to send it down to this device here, and it's going to watch these sessions build up. And it's going to watch the traffic go through. So if you set up your session and that little bug starts going through here, right? Here goes your bug. We're going to send that bug down here, and he's going to see it, and unfortunately that bug's going to go here to your server. Well, at least we know about it. And this guy can set an alarm and say, guess what? A bug just went through your network. We want to protect that network, right? So what's it do? It could actually go back out and tell the network, disconnect them. Disconnect those sessions. There's something wrong with that client. He's attacking your server. Will the customer want that? Saying that's a really important part of his business? Yeah. The network could do that. But I called this chasing ghosts. I didn't like this at all because it wasn't real time. It already happened. The bug already got through. So what we had to do is we had to come up with something different. We had to come up with something intrusion detection, but prevention. We want to put this box not out here, but in here. So he actually filters everything in real time. In real time. I tell you how I explain it to customers when this, and again, the best thing to do is use non-technical explanations of technical terms. Customers will understand that. Let's just imagine we have a highway here. We have a highway. Traffic's supposed to flow this way here, this way here. Intrusion detection would be a policeman standing on the side of the road here. He's standing on the side of the road, and he's got his radio, and his badge, and his gun, his nightstick, and he's watching traffic go by. He's probably eating a donut. And he's watching this traffic go by. And all of a sudden, some idiot from North Carolina comes, and he's driving this way on the wrong side of the road. Well, that cop can try to stop me. But I'm going to zip by him at 60 miles an hour, and guess what? He's going to have to radio ahead, hey, there's some idiot from North Carolina driving on the wrong side of the road. What's going to happen down the road here? There's going to be an accident. Something bad's going to happen, right? That's intrusion detection, but intrusion prevention is actually taking the donut, throwing it away, and putting the policeman in the middle of the road. And then when I come on the wrong line, he goes like this twice, and if I don't slow down, he draws down on me and says, pull over. And he pulls me over, and he takes the keys, and he calls it in and says, I just pulled this guy off the road. Which would you want to have in your network? Which would you want to have? If your applications are only running your business, wouldn't you want to have the prevention? And wouldn't you like to have that within the framework of a network? The same devices that are used to access a network has rules in it to be able to do this? Embedded in all the networking devices for security? Absolutely. And we do that. We have a huge business in IPS. IPS. We can do it on a lot of different products. Standalone products, inside of routers, all kinds of different things. Yes, sir.
Just a query about that in terms of this intrusion detection you're talking about. Is this going to invent this, or is this something that someone
No. This is something that was invented from a networking perspective, a requirement from the networking. As soon as these clients started getting out here and getting infected, and we figured out antivirus wasn't always going to work here, we had to say there should be another layer. It's like an onion, right? This is when you hear the onion approach of security. Well, we can secure the client, but it's not always 100%. So what we have to do, we have to secure the network, and we have to secure the servers, and we have to secure all points on the network. We have to secure it all. So
we have developed our version of how to do that.
Absolutely, absolutely. Our version of it. And again, there were companies who came out and said you can have to buy a separate box for this, and we said, well, hey, how would you like to do it inside the switch that you've already got? Would that be better? Absolutely. Absolutely. The same footprint. Yes, sir.
Sorry, Eddie. So other companies, IPS solutions, so Tipping Point as an example.
Absolutely.
That's the session layer as well.
Right.
They all follow the same.
Yes.
Okay.
Yeah, they all do the same thing. It's just where Cisco has the unique capability of doing it. Because what? You connect up to what? A switch. What if that switch could provide that? The first place you connect up. Wouldn't that be better than to let it go halfway through your network and then have to go through another device? And then you have the multi-vendor problem? Maybe so. Maybe so. Does that make sense? These are all the little things. Yes, sir.
What you talking about Tipping Point, what would they say to that though?
Well, they would say that we really specialize in that. You know, that's our core business and everything. Well, guess what? Nobody's more invested in the network being successful than Cisco. We have the most to gain and the most to lose if the network is not used correctly, right? Nobody has more, nobody in the world has more at risk here. That's why Cisco spends billions of dollars in acquisition of all these little companies and everything to put these features inside of our boxes to differentiate us, because we're the cheapest, right? Yeah. We're the cheapest, right? It's easy to go out there. Buy a switch, get a switch free. No, we're not. We have to bring value with that price, with that. And the value of Cisco is it is a more comprehensive solution across the board. And who's to say that, Tipping Point doesn't miss something, or Cisco doesn't miss something? I mean, there is. And some customers, you know what, for firewalls and everything, they may have two vendors, a Cisco and a Juniper firewall back to back. They may have it like that just for security purposes. What Juniper will catch, Cisco won't, or vice versa. There are customers who do that, and that might be a best practice for our customers. But listen, nobody's got more vested in the network than Cisco. Because that's where we're providing services to the customer. If the networks don't work, people ain't going to use them, and that's not good for when you're selling routing and switching. 52% of your business is routing and switching. Does that make sense? Yeah. So again, Cisco saw this early on. Yes, sir.
Is this only implemented in all the switches, or?
Not in all the switches. The question is it implemented in all our switches? Not all of our switches have this particular feature to do this. Might be a specific type of switches, right? And again, some customers may buy a cheaper switch and then have this work on a router at a branch office. All of our routers do this. All of our routers do this. When we get to security on Friday afternoon, we'll talk about some of the benefits of having Cisco, the Cisco infrastructure, their ecosystem of all the different things where we can find out what's going on everywhere and be able to maybe find out what that bug is first. You know? But there's certain rules that we can put in there and say, hey, if you see anything different, it's a bug that we haven't even named yet. Don't let it go through because it's changed. And networking is simple, right? It always works the same way over and over and over. When there's a change involved and we haven't implemented a change, we're going to call that a virus today and we're going to stop it. It might just be, you know, how many bits are in one field. That might drive our server nuts. Specific application type attacks. We have to be able to say, we have to have these devices look in every field and say, okay, these are the only bits that will allow in there, this is the field that will, and if it's anything different, drop it and tell me about it. And it protects your network day one. And it's got to be inside the network, it's got to be on the devices, and it's got to be on the servers as well. We've got to do this layered approach. We really have to. Because for every good technology, there's 30 people who are figuring out different ways to attack it. That's the crazy part of this. We've got these people with the black hats. And Cisco has to be able to defend against that. So, the session layer. So when I talk to, again, a lot of times, some of this is just conversations you'll have with customers. Again, as account teams, account members, you'll get in there and you'll have an SE get up, and I was as bad as any SE in the world to get up there, and you know there might be one SE in a room of 15 people, and then all of a sudden I get up to do a presentation, a sales presentation, and what am I doing? I'm going to this SE and we're starting to geek out and everybody else goes to sleep or gets coffee and leaves us alone. This is a way for you to get back on track. So if somebody brings up IPS, intrusion prevention inside the network, this is a way for you to easily explain it to a customer. Intrusion prevention, from what I understand, is this. Cop on the side of the road, cop in the middle of the road. Which do you want? It's that simple. Business leaders can see that. Mac can understand that. He doesn't understand all these signatures and all this. He doesn't want to. It's not his job. It's not his job.